Yeah. So basically, I just will show you some bits in GitHub, and all of the commits will compile. And if you are interested, you can read it further and see how far I can get. And what we are going to see is the diffs between those commits. And I just explain what is the motivation behind this. Somebody asked me in Zurich if we could encode O programming in Haskell, and I just give the proof that yes, we can, and that's the proof. The O things can be really encoded in the Haskell type system with a little trick, and I would like to show that trick to you. So first, we have just the main, does nothing.
Please increase the font size a bit.
Nothing changed. Okay. Something wrong, so could you just...
It's just delay.
Okay, even better. Wow. So yeah, still it runs. So the basic things, what object-oriented programming is the ad hoc polymorphism, and we also do like a collecting of functions, and collection of functions can be encoded as an ADT. So an ADT can contain a list of functions, and that was the original idea. Okay, little less. I think that's okay. This font size. So we are going to implement a store, and the store, we can create a store in the normal Haskell way. We represent the store as an IOREF. So we have to create an IOREF computation, and saving to the store and loading to the store is just writing to that IOREF. The next one, we are going to hide away the implementation that actually we use an IOREF, and we can do this function. In this function, saying we have a new store, and from the start value we will compute two computations, which is the first one how we can save to a store, and the second one how we can read from that store. Okay, I just give you some seconds. And now we can encode a store object as an ADT. So instead of a tuple, we create this store, and we save the functions we implemented here as the part of the store, not as part of the tuple. So it is just going to use a new type instead of a tuple. And that's now it started to be or be like an object in an object-oriented language. The next thing, to be real OO, we have to talk about classes, and Haskell type classes are used to encode ad hoc polymorphism, and object-oriented type classes also encode ad hoc polymorphism. So probably we can unify these two things together. And there is some explanation, and you create a store, and also you say this is somehow I can construct a store, and the store has two methods. And renaming this store into store object, you see how objects and classes, what is the connection between object and classes, and also just do the constructor and construct the store object here, and hide away that actually these methods from the ADT, and now you can just access the functionality via the type class. If you are really fond of infix notation, you can do this trick. Also, that tricks exist in some nonce libraries, but I don't like, because we are now kind of encoding. We are using Haskell, so we already get familiar with the Haskell functional application notation, and sometimes it's just more convenient to use the Haskell notation, because if you use this flip dollar, you also have to put dollar every of your applications. The next one, rewrite the Haskell notation. That's the same. That's how we hide things. So from the module, we just say we have the type class, and in the type class we have store, save, and load, and we have the type as a store object what implements that type class. So that's the object and the class. So it sounds like OO programming. And the subtype relationship also can be encoded in Haskell if you use superclass for type class. So it's a little bit reverse than O, but it's still. So restore, the subclass for the store is the reset store, which has the functionality how you can reset a store. And the same trick applies. You introduce a reset store class, you introduce an object for that, and the object has to have a store, because we said here the superclass of the reset store is a store. So somehow we have to have a store, and we encode these reset store object, saying we have one extra operation and we have a store object somehow. But also we could say, instead of store object, we just could say store s as a parameter and creating that way. So we can use as a type parameter to say what was the previous, what is the superclass, super object type of this reset store. So imagine the possibilities, and it's kind of deep topic. And for reset store, you just create a store, you save, you implement the reset implementation and pack it together. The same applies. Reset store object is a store, so you have to do this. How load and save works. So basically, you go back to your superclass, super object, and also you say reset store. That's all. Any questions? Yes?
I would have one question. If it's possible, because for example in object-oriented programming, if it's possible not to have the type in S, like S colon store object in main, like line 50.
Yeah.
Is it possible to do it without the object, without the type?
Without the type, at some point in Haskell you have to fix the type.
Yes.
So if you don't fix it, it won't type to this problem.
The vocabulary.
Yeah, yeah.
But is it possible to somehow do it without it, with the extension or something? So it would be like in OO that you just say S and then store 0.
If you fix like one function and that uses the exact type, so probably not. Because we are aiming for type safety, and we can't really do that polymorphism. At one point we have to fix it. Other question? And if you are interested, it's my Andor PO Haskell GitHub account. Just an example.
We will link all the presentation stuff on the hackathon site, and we will send emails so it shows that you got it. And for every presentation. Okay, so thank you.